Hi guys, and this is me promising to finish up at least these last 3 examples, and I'll probably do example 6 as well. The extra practice ones at the very bottom of the last page we don't have to do, it's just good to have. You can look in your filled in notes for those, but let's go ahead and look at this next one. And I'm trying to figure out how to set up these proportions here. I'm looking for V, U, and W. Here's a couple ways I want you to think about these. You can use different methods. So like for instance, if I'm looking at V here, is there any reason why I couldn't use the Pythagorean theorem to solve for it? And the answer is no. So if you feel better about using the Pythagorean theorem to solve for it, please do so because you would get it correct. Now I'm going to go in a little bit different order with these, and I'm going to actually solve for U first. And I'm going to use the fact that 9 is going to be my geometric mean, and I'm going to use the arrow through method. So like the following. So I'm going to go 3 is to 9 as 9 is to U. And then when you cross multiply, I get 3u is equal to 81, and I get u is going to equal to 27 when I solve for it. So this is 27. So then I need to solve for the missing sides. Well, I'm going to use what I call the snail method, which I know is kind of goofy, but it's really using the fact that you're going from the leg of a smaller triangle to the leg of the big triangle, then hypotenuse to hypotenuse. So I'm going here, I'm going to go for V next. I'm going to go 3 is to V, so that is leg of the small triangle to leg of the big large triangle, as the hypotenuse of the small triangle, which is V, is to the whole hypotenuse here of the big triangle, which would give you 30. So when you cross multiply, you get V squared is equal to 90. When you take the square root of it, actually I'll do that in the next step. So I get plus or minus the square root of 90. That simplifies down to V equals 3 root 10. So that works going that way. Now I can use the same process for W, but guys, again, you could have used the Pythagorean theorem to solve for W because I know 2 sides. I'm looking for the missing one, but we're going to use the geometric means process right now. So we're going to go here, the medium-sized triangle and the big triangle now. I'm going leg is to leg, so I'm going 27 is to W, as W is to the whole thing. So W squared equals 810. So then take the square root of that, and it simplifies out to W is equal to 9 root 10. So hopefully that will give you a way of doing those. But again, you could do the same things with the Pythagorean theorem. All right, let's look at C and D. Now, just to make the point that you could use the Pythagorean theorem here, if you wanted to, using the fact that this right triangle right here, the medium one, you can use Pythagorean theorem to solve for the hypotenuse. Please go ahead and do it if you want. So here you could literally go 9 squared plus 6 squared. So leg squared plus leg squared equals the hypotenuse squared. You get 81 plus what do we get here? 36 is equal to z squared. So that's going to give me 117 is equal to z squared. I'm going to take the square root of that. And that simplifies down to 3 root 13. So 9 times 13 is 117, which is z. So you could use that if you want to solve for z. So just know you have that as an option to do. Or if you were doing this one, if you know what x is, then you can quickly solve for it otherwise. So let's solve for x, and let's use our geometric means, the theorems that we had today. And if I'm doing that, I'm going to go x is to 6 as 6 is to 9. I'm going to use the fact I know that 6 is my geometric mean between the smaller triangle and the big triangle. So leg is to leg as leg is to leg when we're matching it up. So x is to 6 as 6 is to 9. And so I get 9x is equal to 36. I get x, when I'm solving for it, x is equal to 4, which means this whole side is going to be 13. And then I can use that to solve for y, because I can use the small triangle to the big triangle using the snail method. So 4 is to y as y is to the whole thing, because that's leg is to leg as hypotenuse is to hypotenuse. So we cross multiply, we get y squared equals 52. Take the square root of that. Y is equal to 2 times the square root of 13. Hopefully that works kind of cool. Hopefully it works great. All right, so give you some options. So let's go through and let's solve for x, z, and y. So let's just say we're solving for x first. Well, I'm looking at x, and it's the leg of the large triangle. So that tells me I'm going to use a smaller triangle and the big triangle to solve for this, and then I'm going to use the snail method. But really remember, it's the following. So I'm going to solve for x. I'm going to go 1 is to x, as x is to the length of the whole thing, which is 3. Now, remember, it's really leg is to leg of the small triangle to leg of the big hypotenuse of the big triangle is the hypotenuse of the small triangle, right, to the hypotenuse of the big triangle. So when we cross multiply, I get x squared is equal to 3. Take the square root of that. X is going to equal 3. Hopefully that helps a little bit on that one. All right, now let's see if we can solve for z. I'm looking at z, and I'm thinking, oh, this is like arrow through method, because I can see it's the geometric mean between the small triangle and the big triangle. So I go 1 is to z, as z is to 2. So I get z squared is equal to 2, and then we take the square root of both sides. So z is equal to 2. Root 2, excuse me, square root of 2. And I forgot my square root symbol on the other one, guys. Oh, luckily it saved the day. All right, I need you guys in here so you can earn brownies, right? All right, then we still need to solve for y. Now, you could use the fact that this is square root of 2, and then you could use the Pythagorean Theorem. So go square root of 2 squared plus 2 squared equals y. Or you can use our geometric means that we learned from this one and go y is to, 2 is to y. So leg is to leg, as y is to 3. So y is to the whole thing. So leg is to leg as hypotenuse is to hypotenuse. So I get y squared is equal to 6. And so we get y is equal to square root of 6. Does that make sense? Okay, great. Now I want to do just 2 more examples. Like I said, I'm not going to do the last 2. But this is just using a diagram, marking what you know, and then deciding what method, which triangles are similar so you know which way to solve it. So on this one, we have the fact that length of segment PQ is equal to 9. We have the length of segment QN is 4, and I'm looking for the length of segment MQ. Well, noticing that they're asking for this altitude of the big right triangle, I realize I'm using the similar triangles, the 2 smaller ones, the small one on the right and the medium-sized one on the left. And so we're going to use the arrow through method to work that one out. So we're going to go 4 is to x as x is to 9, or you can go 9 is to x as x is to 4. Either way is working with that. So 4 is to x as x is to 9, or you could have said 9 is to x as x is to 4. And really we're going leg is to leg, small leg to small leg as big leg is to big leg, or vice versa. So I get here x squared is equal to 36. Take the square root of both sides. And then remember, I'm dropping the negative because I know it's length. I get x is equal to 6. So the length of segment MQ is going to be 6. All right, so that's how to solve the first one. Now the next one, we're going to label what we know again on this diagram. So I'm going to erase what I have originally here. And then I'm going to look for the length of segment PN. So I'm looking for this whole thing. So the whole length of the hypotenuse, and they tell us the following. They said PM is 12 and PQ is 9. Well, I'm looking at this, and I'm actually seeing a snail happen with this one, because what I'm seeing is we're going from the medium triangle to the large triangle. I can use similar triangles here, and I'm going to go leg is to leg. So 9 is to 12, as 12 is, which is the hypotenuse, to the whole thing, which is x. So when I get this, I get 9x is equal to 144. So I get x is equal to, what do we get? That's right, 16. So the length of segment PN is going to be 16. All right, I think that's good enough for now. The other examples, you can see in your filled in notes what the answers are. So if you need extra practice, that's where it is. And hopefully this will help you understand your homework tonight. All right, guys, don't be afraid to call me at home with questions either.